LSTM and GRU, both architectures are very famous variants of recurrent neural network. And these network architectures can solve the long-term relationship issue a little bit. Both approaches utilize the gate idea, and I will explain what is the gate idea using LSTM. And if you are interested in GRU, and also I very strongly recommend to survey GRU as well. But if you understand LSTM correctly, then the GRU is very easy. Okay. So LSTM structure consists of 3 gate units. And also LSTM structure has one more hidden state called cell state. So at each time, LSTM unit receive 2 hidden state. One is cell state, and the second one is the just hidden state. When the 2 hidden state comes in, and also a new input data point comes in, first we concatenate xt-1 and xt. And then we control the first gate called forget gate. The name of the first gate is forget gate. To control how much the previous cell state information can go through this LSTM unit. Okay, so where we use some parameter here to control the forget gate using the ht-1 xt, and we use the sigmoid function to here. Why sigmoid? So the sigmoid function has very nice property. The output value of the sigmoid function is in between 0 and 1, which essentially having 1/2 value at 0. So sigmoid 0 value is equal to 1/2, and which go to 1 as input go to infinity, which go to 0 as the input value go to minus infinity. So sigma infinity is equal to 1, and sigma minus infinity is equal to 0, and this is monotonically increasing function. Okay, so when you multiply it with the sigmoid output, you basically can control how much the previous information can go through this unit. Okay, so which will multiply some value in between 0 and 1. So here, of course, ct minus has high dimensional value, so multi-dimensional vector can be. Then this product means element-wise product. So to define the element-wise product, at this gate we have to have the same dimensional output. So you have to have same dimensional value in between 0 and 1. And of course, you can control the gate, each dimension independently. Okay, so this is the forget gate. And also the ht-1 and xt control another gate with some parameters. This is the name of this is called input gate. So basically this input gate control how much the current input can, with some parameter, it goes through some tanh nonlinear activation function, and this input gate control how much information of the current input xt can go to the cell state. Okay, so basically here we add the previous cell state after forget gate and the current input and the previous hidden state combination, some information abstraction with some element-wise summation. Okay, so that the cell state contains some up-to-date information with keeping some previous history from CT-1 and the forget gate. And the third gate is output gate, which also controlled by another parameters and sigmoid function. And this name is output gate. Okay, which basically control how much the cell state information, the updated cell state information with hypertangent can be stored as hidden state, as new hidden state. That's it. That's the LSTM basic architecture. Everything will be controlled by 3 different gates, and some information will be manipulated with hypertangent nonlinear activation function and several parameters. Okay, then we can store new information from newly coming input xt, and we can keep the previous information using forget gate. Okay, then why this gate idea is very nice? Essentially, using this gate unit, if you want to keep the past information a lot, and if you want to train the long-term relationship well, you just need to open all the gate. You just need to make all the parameters so that all the gate output becomes 1 or close to 1. Then your recurrent new LSTM unit essentially becomes C0, H0, come here, NXT, and hypertangent, which you go to here, just addition, sum of information stored to hidden state, second LSTM unit, x2, hypertangent, plus hypertangent, h2, and so on. So when every set output is equal to 1, essentially LSTM architecture becomes this. And this C0, C1, C2 just add the previous information, which basically just kind of shortcut, right? Just add previous information. So this is basically just shortcut. So from this property, we can model long-term relationship. And if the long-term relationship is not important, we can simply make the forget gate close to 0, and we can control the input gate and output gate as well. So we can control the gate using sigmoid function and the trend parameters so that we can store some long-term relationship only when we need. Okay, so this is the key idea of LSTM. But of course, due to its very simple architecture and very simple idea, this cannot solve the long-term relationship very well actually. Of course, this is much better than the vanilla RNN architecture, but still people does not satisfied with the result. Still, we cannot model the long-term relationship with LSTM, especially when the relationship between x and y are very complicated. This simple LSTM structure cannot store all the correlations. Right. Okay. So in some cases, we need more complicated architecture to store some more information between x and y. So in that case, we can stack many RNN idea, like deep neural network. So this is one simple idea. So you can use RNN unit to model x1, x2, x3 up to x capital T to make the h1, h2, h3, h capital T. And you can think h1 through h capital T as an input for another RNN. So you put another RNN here with different parameters. So this is RNN with theta 1. You can define RNN with theta 2 here. You can define RNN with theta 3 here with the output of the second RNN architecture. Then you can use more parameters and you can define more complicated relationship between input and output. So you can expect better performance. Okay. So in practice, many machine translators essentially use this kind of idea, stack many RNN architecture. Okay. But again, this structure is really complicated, and this architecture generates very long paths between input and output. So maybe we need to apply some densenet idea or lazynet idea to solve such long-term relationship issue. Okay. So this is the basic story of recurrent neural network, and I strongly recommend to watch the Stanford class video the YouTube video, everything, and I welcome every question related to RNN. Okay, so please visit our course website, KLMS website, and the Classroom webpage, and please participate the Q&A.